Namaste everyone and welcome back to our channel. Today, we are going to embark on an exciting journey into one of Java's most powerful features, the Java Streams application programming interface. If you have ever struggled with processing collections of data in a clean, efficient, and expressive way, then this tutorial is just for you. In this 5-minute animated whiteboard session, we will demystify the Java Streams application programming interface, understand its core concepts, explore practical examples, and learn some essential tips to help you write elegant and modern Java code. Get ready to transform the way you handle data collections. Let us begin our learning adventure right now. Alright, let us dive into the very core of the Java Streams application programming interface. At its heart, a stream is not a data structure itself, rather, it is a sequence of elements supporting sequential and parallel aggregate operations. Think of it like an assembly line in a factory. Raw materials enter one end, undergo various transformations, and a final product emerges at the other end. Similarly, a Java stream takes elements from a source, performs operations on them, and produces a result. Every stream pipeline consists of three main parts: a source, which is where your data comes from, like a list or an array, one or more intermediate operations, which transform the stream, for example, filtering or mapping, and finally, a terminal operation, which produces a concrete result, like collecting elements into a new list or calculating a sum. This pipeline approach makes your code highly readable and efficient. Now, let us explore two fundamental intermediate operations that are crucial for working with streams: filter and map. The filter operation, as its name suggests, allows you to select elements from a stream that satisfy a specific condition. Imagine you have a list of numbers, and you only want the even ones. Filter is your go-to. It takes a predicate, which is a functional interface that returns true or false, to decide which elements to keep. Next, we have the map operation. This operation transforms each element in the stream into a new form. For instance, if you have a list of strings and want to convert all of them to uppercase, map can do that for you. It takes a function, which is another functional interface that applies a logic to each element and returns a new value. Remember, intermediate operations are lazy. They do not process the data until a terminal operation is called. Time for a practical example where we combine these operations. Let us say we have a list of names, and we want to find all names that start with the letter A, then convert them to uppercase, and finally collect them into a new list. This is a perfect scenario for a stream pipeline. First, we will get a stream from our list of names. Then, we will apply the filter operation with a lambda expression to check if each name starts with A. After filtering, we will use the map operation with a method reference to convert the filtered names to uppercase. Finally, we will use the collect terminal operation with collectors.toList to gather all the processed names into a brand new list. As you can see, chaining these operations makes the code incredibly concise and easy to understand, transforming raw data into meaningful results with just a few lines of code. As beginners, it is common to make a few mistakes when starting with Java streams. Let us discuss some important tips to help you write effective and error-free stream code. One common mistake is forgetting to include a terminal operation. Remember, intermediate operations are lazy, and the stream pipeline will not execute until a terminal operation like collect, for each, or count is called. Without it, nothing happens. Another important point is that streams are designed for single use. Once a terminal operation is performed, the stream is considered consumed and cannot be reused. Trying to reuse a stream will result in an illegal state exception. Also, remember that streams are immutable, they do not modify the original data source. Instead, they produce new streams or new results. Always aim for clear, readable pipelines, breaking down complex operations into smaller, understandable steps. Following these best practices will make your stream code robust and maintainable. And that brings us to the end of our 5-minute journey into the Java Streams application programming interface. We started by understanding what streams are and their three-part pipeline: source, intermediate operations, and terminal operations. We then explored key intermediate operations like filter, for selection, and map, for transformation. We put everything together with a practical example, chaining these operations to process a list of names efficiently. Finally, we discussed important tips to avoid common mistakes and write better stream code. The Java Streams application programming interface is a powerful tool for writing clean, functional, and efficient code for data processing. Now, it is your turn to practice. Try implementing these concepts in your own Java projects. If you found this tutorial helpful, please give it a thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java programming content. Keep coding, keep learning, and I will see you in the next video. Thank you.